last year, I think, somewhere around when I broke my foot.
So when everyone tripped
It started turning red and not green.
Well,
But like it would turn red. So somehow power was coming from the computer, but it wasn't able to transmit the information. I don't know. It was weird. So Mrs. Christensen ordered a new cable. The guys got it up and through the ceiling last night. And I think I just need to maybe restart everything. Because like when I try to do this, like it's oriented. But it's not.
But it's just so
But
far
as soon as
off.
I pick up a pen, no, but it's not though.
is it orange?
Look.
Like so far off that's on the others.
Oh,
A smart board?
Yeah.
And then earlier I had the graphing calculator up, and like I was trying to push the buttons, and it was like selecting the Windows menu, but like it's oriented. I don't know.
It doesn't look
It is just a little invisible ghost.
P.S. When you finish writing this, open your calculator and figure out where parametric is. Hint.
Oh.
I left my calculator. I didn't say a word. Where are your notes?
Did I or did I lose
Don't
it?
have them yet. I have copied these notes.
when I did it at the beginning of last year.
It was like
Yeah.
Or all three times.
what?
So I started holding it
Oh, that was
in
smart.
writing.
Oh, the graphic
No, no,
calculator.
no.
Because I started holding it like this, and like my handwriting, this is maybe when I hold it regularly.
Uh-huh.
It's
Oh, okay.
so much neater.
Oh yeah.
I can actually
Oh,
read.
Uh-huh.
I should.
That makes sense.
See, Corey loves you.
He's responding.
I love it.
I can use it, but I don't like do the weird shit.
Why don't you do it?
I hope you know. I know this is recorded.
I guess I do have a spot.
He's not here this month.
Being real but appropriate. Okay, so
Wait, you're the only one gonna watch this though.
We know who we are.
You never know. You never know when you need to go back and review parameter.
what is the official name for the letter T?
Parameter.
Parameter. Oh,
Wait, what? We'll come out, guys.
I will help you what sit down.
No, go
T is the parameter. He's fine. He's taking a break. Hand sanitizing. T is the parameter of parametric equations. There's a third parameter. Heard the word parameter. Probably in regard to like dimensions, like the parameters of. But you can also think the parameters of an assignment, sort of. But there's a third parameter, a third variable. Yeah.
Sorry, last thing. Have you ever told us that the circumference is the derivative of the area of a circle?
Wasn't it a
pi is-
homework problem?
I don't remember, but
Oh, wait,
I
no,
left
it's
it.
multiplied.
It's not pi squared, then you do power rule. It's 2 pi.
No, it's not just power.
It's because no
No, two
pi is
pi.
constant and r is going to be constant.
Oh, yeah.
Yeah. Pi. I'm doing mine now. Sorry, go on.
We can find all the volume formulas too with our discs and washers and things like that, which is kind of cool.
So,
That's what we did last year, but I didn't think about the area and circumference one. Okay, so third parameter T, meaning. Last year we talked about rectilinear motion, one-dimensional motion, and every now and then those equations would have T's. You were doing parametric, I just didn't let you do horizontal movement with vertical movement. So either something was going right, left, or something was going up, down. Was anything ever that you were finding derivatives, etc. with going parabolic? Not unless we were using 1/2 at squared plus b so not t plus x. Otherwise, we were not having anything moving any other way than right, left, and up, down. But what if it's curved? You need parametric equations. We need to be able to talk about its horizontal displacement, its horizontal speed, its horizontal movement, separate from its vertical movement, its vertical speed, its vertical motion. So parametric allows us to say, hey, it's not just moving horizontally to the right or to the left, but it's also moving vertically to the right and up, to the left and down. To the left and down. There we go. So parametric lets us think about two-dimensional motion. Now just imagine it gets more exciting when you have three-dimensional motion. It's not just moving in a plane, but it's also moving outside of the plane. Well, I guess it would actually have to be moving. Never. So, we're going to say that x of t is equal to f of t. Y of t is equal to g of t. They are separate equations. Both of them are dependent. Both of them are dependent on a new independent variable t. T is the independent. X and y are both dependent. Why is that weird for us? Who's usually independent? X. And who's usually dependent? Y. And now we have horizontal and vertical. X representing horizontal movement. Y denoting vertical movement. And both of them are changing based on time. The resulting path is called a plane curve. You guys got it all?
Yeah.
Calculators. I did not get it open. Lane sauce. Okay. Where's parametric? Mode par, not func. Not function. Function is y equals f of x. Function notation. A function f in terms of x. Parametric, well, we gotta change it all up. So par mode, for those of you guys that haven't seen it before, soon to be polar mode. Ooh, sequential mode, that's a good semester. When you go to y equals, what do you got?
T's.
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 And X and Y.
So when you hit the variable button, now all of a sudden you have t's. So if you go ahead and say, hey, x is moving in a direction, I don't know, t plus 2, not in a direction, at a speed of t plus 2. Y is moving, you do like t squared minus 1. What does this mean? Graph it to find the path. Well, that's exciting. But if you're looking at, I'm coming right back. If you're looking at, hold on, the window, I'm going to zoom out. What is different in parametric? When you go to the window, what new is there? What is there that's new?
Oh,
T steps, T mins, T maxes. What else is different?
The table has 3 things.
Well, the table, yeah, those are random values from I don't even know. But there are 3 columns. You have the T and then the X1 and the Y1. That's a pair. Parametric come in pairs. That kind of helps out a little bit. But then also, was I changing the X's or the Y's just a moment ago when I was in my window?
Yeah.
No.
Did anybody notice? I was only changing my
T's.
T's. And how did that affect the graph?
It made it stop.
It made it stop. It didn't make it smaller per se, but it said it's only on this path, or you're only looking for where it is for this short amount of time. Now, if I let time keep going and this thing keeps moving, am I going to see more of where it is? Yes. Anyway, something to keep in mind. You might only see pieces of graphs. You might not see other sides to parabolas unless you look at maybe what was going on before, maybe an application of negative time. If you maybe do a negative to a positive and then you graph it, maybe you'll see more of that parabola. Now, hold on. How can we, if this is like a whole new way you're having like an equation for x's and an equation for y's, how can we take this and relate it to the graphs that we've gotten at least somewhat good at visualizing with our 16 basic graphs from CalcBC? Is that a line? No. Is it a parabola? Seems to be. How do you know for sure? No. You say, well, in general, the squared obviously does affect. However, coming back, you'd say, or you ask yourself the question, what would this be if time didn't matter? If time didn't matter, if I just wanted to see the path, well, how would you get rid of time? How would you eliminate the parameter?
Oh, yeah.
That's an application of what we did in our packet on the back page. If we just want to look at the path, and we don't want to see where something is at different times, we just want to see what's the path that it's on, we say, okay, the whole time thing doesn't matter to me. I don't want to know where it is at 1 and at 2 and at 3 seconds past where it started. I just want to see the path. You eliminate the parameter. Anyway, We'll come back to that in a second. What notes do we have to take?
T is a representative of time.
T is representative of time.
Alright, so it's like. So
And
is it
time
finding
keeps on
speed?
spinning, spinning,
Like,
spinning.
you find speed goes using distance over time.
So one more
Isn't
time.
it? Because the x and y are like distance, and then t is time. So is this like speed?
X is the horizontal. Technically, X itself is the horizontal position. Y is the
Okay, so
vertical
it's
position.
position.
And as time moves, theoretically, if something is moving, so will its positions. And if you take the derivatives of x and y, you can know how fast it's moving horizontally.
And if you had two functions at the same time, and didn't you like subtract their x's and y values to find the difference in speed? Because the times are the same, but then the difference is the distance, like,
You wouldn't want to
Fine.
subtract
or
the x's and y's. You wouldn't want to subtract the positions because that would show how far apart they are,
okay,
horizontally and vertically. But you could subtract maybe the derivatives.
okay.
But remember, the speeds might not necessarily be constant. So you could figure out like the difference between barely. You could find the difference between their speeds at one time. But to say that it's
Yeah.
in general, then
Okay.
For parametric, doesn't matter if you're in radians or degrees.
only if you're doing sine and cosine.
So it doesn't matter when you use trig.
Only use trig. And how it's going to show is when you use trig in a parametric equation, but there are two of them, right? There are two pieces to it. Your T min and T max would need to reflect the degrees or the radians. So ironically, T ends up corresponding to angles. So 0 to 360 would be the T's. Those degrees, 0 to 2 pi. Those radians. Initial point, terminal point. We're not doing vectors right now for those of you that got scared for a second. You can just think of, let's do this example. I like this one. There we go. We're saying that time is restricted. Like, I think you had one of these in your packet. Didn't you? Like, t is between greater than or equal to -2, less than or equal to 5. I made that up, but something similar was in there. If that's the case, it has to start somewhere. It has to end somewhere. If time wasn't bounded, well, then it wouldn't end somewhere. So the initial point, how could I know when, I should say, where the initial point occurs? If you're looking at a graph, how do you know which, was it going up and to the right, or was it going down and to the left? How do you know?
So what we're talking.
Yeah, you have to think about table, you have to think about the times themselves and say, okay, what's going on at t equals, can I just say A? So if you have initial and terminal, there must be for some t, some sort of t interval. Otherwise, there's not necessarily a beginning and ending point, sure. So if you have some sort of restricted interval, t in between A and B, well, you would go ahead and for your initial point, you would say when t equals A, well, hold on, initial point, don't you want location? You don't want time, you want location. So you're going to say, oh, the initial point is going to be x of A, right? And y of A. Where is it horizontally at A? Where is it vertically at A? So what are you going to do for terminal point? Got it. You might be thinking last year, oh, we did stuff like of A and of B, yeah, but we never dealt with x and y at the same time. And for position, we just kind of made it an S, and maybe that's the reason why. Because as you get more practical, position can't just be defined by one variable. How to sketch, form a table. You guys got this from the summer packet, hopefully, yeah? In the sense of whichever way you orient it, I'll do it this way for sake of illustration. Now you need 3 rows or 3 columns. You have t's that then determine x's and y's. Does that make sense? You don't need to show much more than that. Depends on your interval. Some of you might think a little bit more deeply and say, yeah, but in the example you just plugged in like all the whole numbers. What about the fractions? Well, long story short, if we eliminate the parameter and see what the path looks like, and if it is a normal function that's not too funky, we can say, oh, hey, well, between t is 1 and t is 2, it's going to follow the behavior of the path. So if it's a parabola, well, if I know this point and this point, I know they connect it with the curve. Does that make sense? If it's a line, when you eliminate the parameter, okay, fine, to connect this point and this point, I connect it with the line. Plot the points in order of increasing values of t. ¿Por qué? Why increasing values of t? Time moves one direction without going into. Go ask Brian Ortiz about his C7 physics class. He'll tell you more about time. But I'm confused. Some people say so. In his class, they went off about like light speed and how time moves differently for people at different speeds. Orientation, what's that?
It's where you meet new people.
I'm going to say this is initial. Just for sake of illustration, I'm saying that's initial and that's terminal. And if that's true, how do I show my orientation? The arrow should be going. I can say, hey, look, it's going this way. How do I know that? Well, that's the initial, that's the terminal. And if you eliminate the parameter, well, that's the curve. Okay, cool. Going that way. If the orders were switched, if initial was up top and terminal down bottom, the orientation would be?
Are there an easier way to like graph the whole curve and everything, or do you just plug in points?
Eliminate the parameter. Well, eliminate the parameter. And then see if it's a function that you know, if it's a quadratic, a cubic, a square root, a trig. By calculator, oh, we already talked about it, no big deal, sorry. Mode. R. Have fun. Watch out for in your window, watch out for your T's, and we'll talk about that as we go. A grapher can draw a pair Y. This is pronunciation, not pronunciation.
Parametrized. Atrized.
Should we write that down? Premature.
It's para.
Parametrized.
Parametric.
Parametrized.
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 That's
I was laughing because it sounds funny. I wasn't laughing at you.
Parametrized.
See, in my head, none of them sound right. I don't know. Something weird.
Parametric.
Long story short, you will only have endpoints when you have a closed interval. Does not mean that you will only have a finite path if you have a closed interval. There can be a function that is enclosed, like an ellipse or something like that, but something's just going around it multiple times, like around a track. Okay, it's up to you as to whether or not you want to write it, but I thought that was a good note to talk about. Ready, set, graphing calculator, go. Get it in your graphing calculator so we can go ahead and analyze it by hand. I left my by calculator up just so that we can jump very quickly. But go ahead and get it indoors. Because you guys will not necessarily have the same window as that. So put in the X, put in the Y, and then just graph it.
That's the standard window.
Depends.
Well, if you reset it, that's what no.
It is 10 by 10, but remember the T's. Can anybody tell, Kyle, let's go with your question, what mode I'm in right now?
R.
Oh yeah, but what else?
Radians.
Radians.
Because it's 0 to 6.2. So if you hit zoom standard, it's going to do 0 to 2 pi.
Double pi.
So the T's, as I was telling Kyle, correspond to angles. By hand, how do we do it?
How'd you put the T's down?
You have to eliminate, you have to plug in the
Just 0 to 2 pi and then pi over 4? No.
I don't know.
Pi over 8?
3.5.
I don't know. I've never actually worried about what that was precisely. I just do the 0.1 if I need to make it something more. Okay, by hand, what will we do?
icons. I would 24. Yeah.
If it does not tell me otherwise, where should we start time?
0.
Plugging in 0. I have 0, 1.
Mm-hmm.
Initial point? 0, 1. Initial being, remember last year, initial time is 0, so they do not tell me to think about negative times, which could be like just backwards from some reference point. They don't tell me, I assume it starts at 0. Plugging in 1, I have what, 1, 0? Plugging in 2, I end up with 2, negative 3. Plugging in 3, I end up with 3, negative 8. I'm guessing it's there. If I was sketching my graph, what we're going to do besides what you see right there?
Arrows.
And since there's no restriction, I would just go ahead and show it. I mean, you can show multiple arrows, it was kind of cool when you do it, but we're not ending it because it doesn't show me a closed interval, right? Does that make sense?
Do all parametric graphs like curve in such a way that it looks like it's increasing in speed, like, or give?
Not necessarily, because if you were on an oval, it would increase and then decrease, and then increase and then decrease. Like, because your slopes would be steeper and less steep.
Okay.
So not necessarily. But in this motion, yeah, it would seem to assume that. Which makes sense, just in figure in physics sense, right? So what's the purpose of eliminating the parameter?
To find the path. Function.
We have to deal with this, but if only we could get it to be, we're like, oh yeah, that's a parabola that shifted up 1, right? Yes.
Yes.
This is hard for our brain to comprehend, especially when x is not just t. And especially when x is not just a linear expression, it's going to get hard to comprehend. Like, what if x is cosine, y is sine? I'm getting that.
Cos.
But this makes it easier. This meaning eliminating the parameter. Now, the nice thing is you guys already reviewed this. I should stop saying this. You reviewed eliminating the parameter in your summer packet a little bit, maybe without full context of what you were doing. So a description of what you're doing when you're eliminating the parameter, you're saying, I don't care about the timing. Another way of thinking about it is I only care about the path. So you don't care where it is on the path at a certain time or at a certain future time or where it will be on the path. All I care about is what's the path look like, which is what would help me with graphing, right? Now, don't do the example that you see because that one is the one we just did and we did it really fast and you guys don't need to spend time on it, right? We'll do another example in a second. And a simple way of saying it is just take the x of t for the horizontal position function. Solve for t, plug into y. What are we doing? Getting y as a function of x. What are we doing? Disregarding the time. What are we doing? Eliminating the parameter. What is the purpose? You guys gotten it by now? What's the purpose of eliminating the parameter?
You don't have to use the 12 anymore.
So you can visualize. Yeah, so you can visualize that.
What kind of diet are you eating?
What?
Say the 38 thing, I don't know what it is. Do you have to eat at a certain time or something?
I'm supposed to eat every 2 to 3 hours. But I have breakfast at like 6:30.
Yeah, that's actually healthy.
So,
What do you call
when
it?
I'm when I'm teaching, I'm supposed to be eating again.
I mean, what do you mean eat though? Like eat snacks or actually meat?
Oh, well, it's breakfast and snack and lunch.
Okay.
Dinner and snack and then.
You can eat them full. I don't think it's basic.
No, I know, but I'm still late. I was supposed to be eating like 20. Well,
No.
3 hours ago. I don't eat, and then I have to get to work. Okay. And so 10:30 at night, maybe you last night. You guys are good, right? That was fast. Ready, set, go. My directions eliminate the parameter. In order to do this problem, my directions would be eliminate the parameter.
I just heard it over here. That's crazy.
I'm laughing. Consider it.
I compliment her hair every day.
Yes.
You have fabulous hair.
What are you guys thinking? How are you going to eliminate the parameter?
Get the key by itself and plug it into the other one.
That is what the description on the page before would say. That is not what I would advise.
Plug it into the other one.
Nope.
So,
By
All
hand.
for cheap.
oh, so,
Nope. That's not what I would advise, even though the steps on the page before and for simpler non-trigonometric functions would seem to indicate that.
Table. Happily.
Sine squared of t plus sine squared of t is equal to
Pre-calc
1.
kids, remember?
Yeah.
Other kids, you're about to get your minds.
Oh,
Isn't that a really cool identity?
yeah, that's cool.
Don't we have stuff with cosine and sine?
Yeah.
Don't we want to make an expression with the sines and cosines and have them go away?
Sure.
Yes.
If we get rid of the sines and cosines, don't we get rid of the t's? So, what if we take the x expression and say, hey, then x squared would be 9 cosine squared?
Okay.
Oh, this is where you're going with this.
And then I could say, well, cosine squared would then be x squared over 9. True?
Uh-huh.
I have to take a couple steps back from the problem to go about it a whole other way.
It's
It's
a
circle.
circle.
And it's sine.
Y squared will be 3 sine
So
squared,
agree with the radius of
which means sine squared will be y squared over 9. Oh, did I not make that 9?
But wouldn't it be 9?
Fail. I
Sine
know,
squared
I
is
know,
3.
I know. Shh. See, another reason to be real. The math teacher can't even get it all right. How can you guys do that?
Because everyone makes mistakes when you make mistakes.
So, can't I say cosine squared plus sine squared is equal to x squared over 9 plus y squared over 9, and all of that is just 1 by the definition?
Yeah.
So can't I say, who's this guy?
A circle.
Yeah, he is. A circle with a radius of
3.
I got you. Katrina.
Thank you.
Caroline did probably agree.
Question though. I see the path. X squared plus y squared is 9. You can multiply everything by 9. It's a circle with a radius of 3. But how much of this circle am I drawing?
Only the parts from 0 to 2 pi.
That's the
whole-
entire
that's
circle.
Multiply everything by 9. X squared plus y squared
Not
is
if we
r.
move it. Ooh, funny
We'll save that for Colton. R equals 3, yeah?
Yeah.
Where's my initial point? Plug it in, plug it in. Cosine of 0 is 1. Sine of 0 is 0. So I have 3, 0 as my initial point. Where am I starting from? Right here. Where am I going? This direction. How long am I going that for? 2 pi, which is going to in fact end up being what?
Circling.
Whole circle.
Then how do you know which way it's going?
We started.
Because I plugged in, what's x is 0? What's y is 0? So I knew we were starting here. And then I didn't follow up, but I could have gone ahead and then plugged in like pi over 2. And I would have been here, and then like, oh, we're going this direction. Sorry, you're right. Technically my explanation just assumed we were going counterclockwise. That's dangerous. What do you think we're going to do anytime we see any trig in a parametric equation? We're going to square both sides and try to plug into a trig identity. But wait. What if we have secant and tangent?
There's no
That's a trig one.
1 plus tangent squared is secant.
And so is cosine and cosine.
Yeah. So any trig functions we see, wait. So any trig functions we see, we're going to have x squareds and y squareds? What are the special shapes called that have x squareds and y squareds with pluses and minuses and division-y things? Conic?
Conic section.
So can you have hyperbolas and ellipses and circles and all sorts of things?
Yay!
Although that should have been a circle. It's like an ellipse. I apologize. Hey! Homework number 1!
It's not on the board in order to do it.
No, wait.
Where's
Is it tomorrow?
It's not on the board. It's not on the board. It's not on the board. It does not do tomorrow.
We will not check homework until Monday, but I'm not sure if that helps my seniors
Woo!
at all.
We
We're
got
going on and hold there tomorrow for the half hour that we have before you leave.
Well, we get back the time I start homework.
They can go up.
Miss D? Hyperbola. 이 스타일이 좀 보이면서. Your eyes are already really good. Are you hungry?
Oh, I'm on day 18.
Oh, so you're kind of used to it. It just was off.
I just was teaching, I just can't fit them in. I'm having issues. I'll work
It's
on
okay, you
it.
can sneak it on your desk.
Yeah,
Like the
there you go.
students do.
Under my desk, I'll sit back here. You
Yep.
guys do work, I'll just be chilling. Crunch.
Someone left their Bible here.
Uh-oh. Can you just put it like on the tray at the front?